Calculate the following question with hand and calculator. Provide the steps. If a watershed has average net radiation 185 watts per meter squared, air temperature 28.5 degrees Celsius, relative humidity 55%, and wind speed 2.7 meters per second at height 2 meters. Assume standard atmospheric pressure 101.3 kilopascals and Z naught equals 0.06 centimeters. Calculate the open water evaporation rate in millimeters per day using the combined method. By writing down our givens, we have net radiation is 185 watts per meter squared, temperature is 28.5 degrees Celsius, relative humidity is 0.55, wind velocity is 2.7, Z2, which is our height, is 2 meters, and you can convert that to centimeters, which is 200 centimeters, and Z naught is 0.6. We'll start with LV, which equals 2.501 times 10 to the 6 minus 2,370 times temperature. And when you plug that in, you'll get 2.43 times 10 to the 6 joules per kilogram. So then we can do ER equals Rn over density of water times LV. And then you're going to have to multiply by 86,400 so that we can get it into millimeters per day. And we know the density of water is 1,000 kilograms per meters cubed. So then you'll get 6.59 millimeters per day. Then we can solve for B, which equals 0.102 U squared over the natural log of Z squared over Z naught, all squared. And with that, we will get 4.19 times 10 to the negative 3 millimeters per day Pascal. And then we can find EAS, which is 611 times E to the 17.27 T over 237.3 plus temperature. If we plug in our known values, we'll get 3,892.7 pascals. And we can use this to then find EA, which is relative humidity times EAS. And then we will get 2,141 pascals. And using those, we can find EA, which equals B times EAS minus EA. And this will give you 7.331 millimeters per day. Now we can find delta, which we'll need for the E combined equation. So that's 4,098 times EAS over 237.3 plus temperature, all squared. And that'll give you 225.8 pascals per degree C. And we know that gamma is 66.8 pascals per degree C. So our E combined equation is then equal to delta over delta plus gamma times ER plus gamma over gamma plus gamma over delta plus gamma times EA. And when you do that and plug in the numbers we got, you get 6.76 millimeters per day. And that is your final answer.